recording. Hey guys, first off, I want to welcome everybody to today's webinar presented by Gita. We've got a great presentation for you guys today. I can't wait for you to see it. I'm super excited about it. These guys reached out to me and said, hey, we like what you're doing. Let's get together and let's do something. So Kevin and Travis are on here. I'm super excited about it. Before we get started with those guys, I do want to make a couple of announcements for GITA. You'll notice that we have sent out ballots for the executives for GITA. So president, vice president, treasurer, and secretary. This is going to be the easiest ballot you ever fill out if you're a GITA member, because everybody's running unopposed, which is fantastic. But we will be making an announcement in January of our 5 new at-large board members. Can't wait to introduce you guys to them. If you are interested in doing a webinar with the organization, please reach out to me. We are happy to provide that platform for you guys because it just provides value to the membership. If you are currently a member of the organization, thank you so much for supporting the organization. For without you, we don't exist, and we exist for you. If you are not a member and you want to know what the value is, president@gita.org. Reach out to me. Let's set up a call and let's have a conversation, right? Guys, Thanksgiving is next week. We've got some education for you right now. And we've got Kevin and Travis from One Spatial here talking to us about getting your geospatial data ready for next generation data models. I'm super curious to know what this is, guys. Let's get right into it.
Excellent. I appreciate it, Drew. So my name is Travis Schindler. I've done a presentation, I think, for y'all in the past. So appreciate y'all having me back. I have Kevin on here as well. He's our director of solutions as well as operations at One Spatial, and I'll let him talk a little bit more about him here in a second. But just a quick background. One Spatial, we are a GIS kind of software company. So what we do is we work on taking your data and validating it, cleaning it up, enhancing it, getting ready for kind of these next generation data models that are coming out. So it works in different analytical packages such as outage management solutions or linear referencing systems, different, so you can run different types of analysis against it. So who we've kind of worked with in the past has been a lot on the government side, everywhere from the DOTs to the Federal Highway Commissions on doing some automated QA, QC validation and cleanup. So we're doing a lot with the highway performance management systems at the federal and state level, as well as we are doing some next generation 911 work at the state level as well. Maryland is a perfect example of that, where the counties work with the states to upload their data to the state using the OneIntegrate package. So these are just a few of the companies that we work for or work with and partner with. Some on the utility side in the commercial sector that we work with, which I know that's where most of y'all are probably fall into, but we are working with a lot of electric and gas as well as energy companies. One of the big ones that you see there under our global clients, we're actually doing a Esri utility model network migration, helping them do that over in the UK. So we do have quite a bit of utility work and energy work going on. I'm doing specifically around the Dallas-Fort Worth area, working with a few companies in that realm. And then we also are working with other utilities like telcos, and then as well as we're allowed to say Google. We're working with those guys on some of their CAD validation and integration within their worldwide real estate services group. So with that, I'll turn it over to Kevin, and he can kind of maybe fill in the blanks a little bit and start jumping into the demo.
All right. Thank you, Travis. Hi, I'm Kevin Sigwart. I'm the CEO of One Spatial Inc. And we do a lot of work with data cleanup and data migrations and getting your data integrated into these new data models that are coming out. So if you're planning on migrating over to the new Esri Utility Network model, you need to get your data cleaned up before going in there. So we're doing a lot of work with helping organizations with these types of efforts. We've done a lot of work on the transportation area that Travis mentioned before, getting the data ready to go into these other Esri data models like Esri roads and highways. And that getting the data into those types of systems requires a lot of validation and cleanup, and doing it all manually sometimes can be a little too much work for an organization. So having automated tools to help facilitate that can really help you, and that's a lot of the work that we're doing. So I just wanted to highlight one of our customers that we're doing work with in the utility realm. This is with water, but we've discussed a similar solution with some telco companies, and they're really interested in this idea of building out inferred assets or taking away inferred assets in some cases. So for this particular client, Northumbrian Water, there was an effort where they were getting the responsibility of handling wastewater from the federal government over to these companies. And as part of that effort, the government was going to give them a stipend for the amount of pipeline that they were now responsible for. Well, when they got the data and they looked at the data, they realized all they had was the water mains. They had none of the lateral information. So in order to do that assessment to find out, well, how much pipeline do we actually have in order for us to get that stipend, they were like, well, if we go out and we manually try to assess every single one of these laterals, it's going to take us 15 years and 30 million pounds to actually do that effort. And one, that the stipend alone is not worth that much. And two, it's just going to take too long. So they say, well, is there a better way we can do to actually identify this information? And they contracted with One Spatial to help build out and infer where these assets were located. So as part of this effort, we first validated their network and asset systems, making sure that there's no sort of issues with connectivity and things like that. We then brought in data sources from a variety of different databases. So we brought in the GIS data, we connected into their CRM systems. We grabbed data from Ordnance Survey, which is kind of like US Census, NGA, and a variety of other organizations all built into one large geospatial organization in Great Britain. Well, they have, and there they have like information about parcels, building footprints, and so forth. Well, with all that information, we can actually infer using business rules where the pipelines would be based off of all that information, bringing in that, the customer data and the GIS data and that Ordnance Survey data. And we were able to build out those inferred assets. Well, as part of that effort, one of the additional things, not only were we able to identify those inferred assets and complete that project within 2 years and only at $1.25 million, but they were actually also able to identify any sort of missing account. So they realized, wait a second, there's accounts that we're not billing that are there that we should be billing. So they were able to actually find new revenue streams too through doing this effort. So there was multiple different use cases where they were able to help out in this particular effort. And to do this, this is where, I'm getting ahead of myself. So now back to the actual presentation that we're talking about is getting your data into these new utility network models. One of those out there that organizations are looking at migrating into is the new Esri utility network model. And data quality really matters. If you try to push your data into this network model without doing a proper assessment, it's going to be a massive headache. There are the geometric network model, or the geometric network, was a lot more forgiving than the new utility network model. So before migrating over, you want to make sure you assess the data, because once it gets into that system, if it is the way that it is processing the data, if there's issues, it's just going to start slowing down to a crawl. So Esri suggests to do some sort of assessment of the data before getting the data into that data model. So that's going to really affect your performance. But beyond that, even if you're not moving over to the new Esri utility network model just yet, there are other tools that you're leveraging that GIS data for. There's modeling software out there that when you're trying to bring that data into the modeling software, if it's not accurate and correct, it's going to give you either it's not going to work because you're not dealing with a proper network, or you're going to run into issues where it's you're going to get the false answers. You're going to get because the data is not necessarily accurate, and then you're going to lose trust and credibility with whoever is that those analytics are providing information to. Beyond that is this data is also being used to sync other systems. a lot of organizations are looking at master data management, and if you are trying to bring data, integrate data sources together, if there's data quality issues, it's not going to integrate properly. There was actually a study done where they found that 88% of data integration projects fail, and the main driver of that is data quality. So making sure you get your data into a good set of quality data before doing these integration projects is extremely important. And then there's also a lot of these new network models and new database systems for utilities and other geospatial data sets requires these application and triggers. And if the data is not correct, things aren't going to fire off when they're supposed to be fired off. It's going to degrade your system as time goes on. So with that, as I said before, we at One Spatial, we focus on data management solutions. And when we're talking about data management, we're really talking about these three main aspects, and that's data validation, data integration, and data enhancement. So we have a rules-based engine, our OneIntegrate product, that's our flagship product. You can define the business rules of your data, and then anything that doesn't conform to those business rules gets flagged as non-conformances. Now we have whole sets of rules that are already configured in the engine, but we understand that whenever we're working with the client, their rules are always slightly different than somebody else's rules. So we're not going to hard code rules into this system and just say you have to have those same rules in order to make sure that your data is fit for purpose. You have your own data governance, and you have your own policies, and you may have your own schemas that you need to write your rules against. So we provide that flexibility where we could start with a set of starter rules, but then you can expand that out to meet your exact business needs. And the application is that flexible enough to do so. And I'm going to demonstrate that shortly. But beyond just doing data validation, we can also do things like data integration. So we can bring in data sources from multiple different, or bring in data sets from multiple different data sources. Like I talked about for the Northumbrian water example, bringing in data from 3 separate data sources that were completely siloed off: the CRM system, the GIS system, and then some third-party data sets through Ordnance Survey Great Britain. We can connect into those systems. One could be in a SQL Server database, one could be an Oracle database, and one maybe be PostGIS or Postgres. We could bring those into the engine and write validation checks across the entire enterprise. So the more data you throw at it, the better idea you can get. Is there any sort of discrepancy between your different data sets? And then lastly is data enhancement. As you're doing these assessments, you're going to find that, oh, I may have a lot of data quality issues. And if you try to manually correct all those data quality issues, it may take a really long time. So you may want to be interested in automating some of that cleanup. So in the engine itself, you can define how to clean the data, and it will automate that process of cleaning the data, getting rid of kickbacks or getting rid of kinks in the network, fixing overshoots, undershoots within a tolerance. So just snapping the network together. If your meters aren't connected to the laterals, like connect those meters to the laterals, things like that, you can automate, and you could do it in a systematic way because you're going to find those in business rules. Beyond just doing data cleanup, if you're doing data integration projects where you need to keep your data up to date and you're bringing in data from other data sources. So some examples are you're bringing CAD data from the engineering drawings and you want to bring it into your GIS. Well, we can also facilitate that. The CAD drawing can come into the engine. You can write business rules for how to integrate that data into your GIS and integrate that into the GIS. And I do have a use case where I will highlight at the end, showing where we're bringing in electrical manhole drawings that were in CAD into a GIS. And those manholes had no geospatial information at all in them. They were all in paper space, but how can we integrate that into the GIS space? So with that, I wanted to first highlight, I'm going to do a gas example and an electric example, but we're going to dive a little bit deeper into the gas example to start with. And then electric's a little bit more complicated. So we'll start with gas, and then we'll expand out to showing you some examples with the electric too. And what we're going to do is we're going to take a gas network and we're going to run it through a series of validation checks, leveraging the OneIntegrate technology. Now, I just wanted you to keep in mind that all of these business rules, none of them are hard coded in there. So if you're like, well, that doesn't really make sense for my particular use case, it can be configured to your exact business case. And I'll show you that too as we're going through it, but just keep that in mind. And then beyond just doing these validation checks, we're going to also show how we can do some of the automated cleanup too within the engine itself. So with that, let's start. We're going to start in ArcGIS Pro, and I'm going to use ArcGIS Pro as my GIS visualization software. This is not where we're doing any of the processing. All the processing is going to happen inside of our OneIntegrate product that doesn't use those Esri libraries, but we need something to visualize the GIS data, and a great product to do that is ArcGIS Pro, but you can use whatever GIS product you have, whether it's ArcGIS Pro, ArcMap, you may have, some sort of a QGIS or what have you, or maybe you're working all in CAD and you're dealing with CAD software. We can also work with that too. So here I have an a gas utility network, and let's just zoom in so we can see what we're dealing with. And in here we have, a series of, gas lines and so forth. And what we're finding is that, well, one, I'm looking at this and it is symbolized based off of a set of interesting symbology that may be good for visualizing the data itself, but not very good for doing validation. So I'm going to flip this over to something that's a little easier to understand when we're doing the validation checks. So we're going to flip this over to the symbology. And what we're going to do is we're going to run a series of validation checks. Some of the validation checks we're going to check for is proper connectivity. We're going to look if there's any kinks in a network. We're going to make sure that our lines are what should I say? We're going to make sure that our service lines are actually feeding out to those service points, and we're making sure that the relationship is that the service point is connected to the end of the line. So not just that it's connected to the line, but it's connected to the very end of the line. So we can already see over here. Here's an example where the service line is not connected to the meter itself. So we're going to run it through a series of validation checks, and to do that, we're going to leverage the OneIntegrate technology. So now I'm going to flip over to OneIntegrate. And here is our OneIntegrate product. This is, as I said, this is a product. It's a server-based product that can either be installed on-prem or it can be hosted in a cloud environment. And the way that it works is you have an interface for building rules and running rules. It also has a REST API. So a lot of this occurs through automated processes. So things kick it off and it just runs through. So you may not necessarily work with the interface itself directly, except when you're just building out what types of validation checks you want to run. But all this can be also automated through a series using the REST API. And what we're looking at here is we're on the sessions tab. So this is where we're connecting to data sources, running validation checks, running cleanup, writing data back out, and so forth. And that is made up, as I said before, of data stores, which is where we set up the connections, rules, where we write business rules against the data. Actions are what we do when there's a non-conforming business rule. Do I want to report out where the issue is occurring? Do I want to clean the data? And then an action map is how we tie a rule to an action. So I'm going to go ahead and fire this off. And what we did is we brought in some 87,000 objects. So we're bringing in about 20,000 distribution mains, 30,000 meters, and 33,000 service lines. I could bring in everything, but for this case, I'm just doing validation checks on those 3 different data sets, 87,000 some features, and we're going to run it through 30, 40 business rules. And this is only going to take a few minutes. The reason we can process through this much data this quickly is that under the hood of OneIntegrate is an object-oriented database that indexes each individual object so that we can do quick feature-to-feature comparisons in a very performant way. So we can do these really complex validation checks against very large data sets in an extremely performant way. We did a validation. We validated a large utility network that was out in California that was like I think it was 30 million records, and we were able to validate that against a series of validation checks, probably 14 or 15 validation checks, and it took about 24 hours to run through. So, doesn't matter. The application scales really well for very large data sets, and this is why a lot of we work with a lot of utility clients, but we also work with a lot of national government agencies because they also have very large data sets, very complex business rules, and they need to be able to chunk through that data in a very performant way. So what we're doing here is the first set of validation checks are our essential geometry checks. They're checking for typical geometric issues that we find in most GIS data sets. Things like duplicate features, kickbacks and spikes. Those are kinks in the network. Things like features contained in other features, duplicate features, and so forth. And what we're doing is we can see that we're getting a conformance percentage based off of that validation check. So running the duplicate vertices, we can see that of my 87,000 features, there's 132 features that have duplicate vertices in the data set. This occurs a lot of times when especially when you're, most GIS data these days doesn't create duplicate vertices, but I typically see it when I'm bringing in CAD data in that GIS. I always see duplicate vertices in the CAD drawings. So that's typically how this gets introduced into your GIS data. I don't think if you're using Esri technology, at least you shouldn't be getting duplicate vertices if you're creating it inside of the Esri technology. What you will get is you will get kickbacks and spikes and things, and where you're double clicking when you're trying to close off a polygon, and it creates a little kink in the network or whatever. But then we're also here's some pipeline checks. We're doing attribution checks, making sure my attributes are populated correctly. We're going to do some geometric checks, making sure that we have proper connectivity. We're going to do, making sure that the length of the pipes are meeting a certain threshold. We're going to make sure that we don't have any isolated pipes. We're going to look to see if there's isolated pipes based off of the pressure. And we're going to make sure that if pipes are connected, they must have the same pressure within those pipes that are connected. Or if not, there should be a valve there that allows you to change the pressure. And then lastly, we're doing that is making sure that the services are connected to the pipes and making sure the meters are connected to the services at the end of the services, and so forth. And so just as I said before, we just ran through those validation checks. I don't know how many, but quite a large number of validation checks. And we did it in a minute or two. And this is where we're talking about that whole performance, is being able to get through your data in an extremely performant way. Beyond just seeing this in an interface, seeing what the validation results are, you can also export those results out so that you can bring them into your map. So what I've done is I've exported those out, and we can bring them into my mapping application. So let me go ahead and turn on my markups. So this is identifying issues with my data set. Remember, I said that there's these particular 2 points. The meter is connected to the wrong side of the service line, so we're flagging that as a non-conformance. If we come over here, here's where we're flagging this as a duplicate feature. I have 2 service lines that are the same geometry. Also, it has the same attribution too, so we can make it smarter than just the same geometry. We can also look at the attribution too. Here we have an example where we have a duplicate vertice. So if I come in here and look at this geometry, I'm sure, oh, here we go, right here. Here's 2 vertices that are duplicate vertices. We have spikes and kickbacks. I see this all over in GIS data, where there's these like, kickbacks and spikes and weird issues with the data as it's trying to maintain connectivity. This is going to wreak havoc if you have any sort of like model, if you're trying to feed this into modeling software. Here's another example where we have a spike. And then here's just one other example where there's this weird spike occurring. We have features contained in other features. Here's another example. Oh, what's that? Okay. Here I have 2. Let's see here. I have 2 features that are one feature, it goes to about here. The other feature extends out, so they're contained in there's one feature contained in another feature. Proper connectivity. Here I have an undershoot. I can look at, here's another example of an undershoot, and then I also have, where we have pressure mismatches between connected pipes. Here we have an isolated pipe, because I'm looking at not just is the pipe connected to another pipeline, is it connected to a pipe with the same pressure? In this case, there's a mismatch, so it's a pipe that is isolated by itself. Making sure we don't have orphan meters. So here's some orphan meters where it's not connected. I already mentioned this before, where it's not connected to the end of the line. And then lastly, one of the other validation checks that we've done is also check for where do my service lines cross over my pipes where they don't have a jump in them. And jumps are great for when you're dealing with it's great if you're dealing with like a paper map per se, but if you're trying to deal with like running this through some sort of analytic software, you're going to need to be able to handle it. So you're going to need to be able to identify where do we have crossings that are where there is a jump, so it's not actually connected. So maybe you want to change the Z value or something like that so that they're not actually connected. And where do you have ones that are just crossing over? So we can, in the rules, we can write business rules to determine whether or not it's crossing with a jump. So this is where we have that the cross here where we have a jump. And then this one is a straight line. So it's crossing over, but it's not a jump. So we can write some pretty complex business rules. All of that was done, all those validations across this entire data set was run, in that short amount of time. But beyond just doing validation checks, we can also automate the cleanup. So I'm going to go ahead and fire this off. So now we have business rules that are running that are going to do the automated cleanup. Just like we had the essential geometry checks, we have essential geometry fix-ups that can remove those duplicate features, fix connectivity, things like that. While this shouldn't take that long to run, but while it's running, let's take a look at what some of the rules actually look like. So let's flip over to, let's see, I'm just going to flip over to this particular check here. So in this check, I'm making sure that for my distribution main, the material field is not equal to null. So we could choose which feature class we want to validate against. It brings in the schema. I can say which attribute I want to validate against. And I'm saying here it's not equal to null. But maybe it's a domain and we know which values it should be equal to. So then we could say, it must be equal to, and let's say, let's say it's, I don't know. I don't want to say lead, but let's just say lead. And we can say, whatever it needs to be, you can just build this out. And then it's just anything that doesn't meet those actual values is going to be flagged as a non-conformance. As you can see, we could take the rules and we can extend them to our liking. Now, this is just an example of validating the attribution. But what about if we're going to look at some geometric checks? So let's look at one that is a, let's look at, where's my containment one? Well, here's when we were looking for self-intersections, looking for a minimum length, isolated pipes. So I'm saying that for any given distribution main, there's another distribution main where it intersects. We can look at isolated pipes based off of, a specific pressure class. So we're looking at low pressure. We can be pressure specific. So we're looking at, do they intersect and they have the same standard operating pressure? So we're doing a geometric check and an attribution check. And we can get really specific. So here we're making sure that the geometries are connected at the end or the start of the geometry. So you can write some pretty complex validation checks to meet your exact business needs. So if I flip back over to the session, we should be just about done. So we're almost done. We have a few more rules to run through to do the cleanup. And then after we do those cleanup, we can write those back to the database and then visualize those cleaned up data sets to see what we actually did. So let's go ahead and flip over to that.
And Kevin, there's no programming in any of the rules, right?
No, so everything you saw there is configurable in the interface. We're just using that GUI to define the business rules. And that is, and I guess beyond that is that, this is also when we typically are, when organizations are working with our software, they also do training. So they learn how to write these business rules in the system so that they can get up to speed and write their own business rules and maintain the system themselves. So let's go flip over to some of these example issues. So where we had the duplicate feature, this is a pretty simple one. When we clean it, there's that duplicate feature has been removed. We just remove it out. Pretty simple. Where it gets more interesting is dealing with these these spikes. So here I have a spike and I can clean that up where we remove that spike, but we're still maintaining the topology. So we had that proper connectivity when we remove that spike. Same thing for this one here. So it's kind of hard to see when it's cleaned, right? So let's flip back over Right, that was the one I was just on. Let's go to this one. Here's another example. When we clean the data, it removed that spike. And same thing for this particular example, where we had the weird kickback spike. We then fixed it, had proper connectivity. Where we had that overshoot, undershoot, or in this case, an undershoot. Here we have that undershoot. When we fix it, it's now aligned. And then if we're looking at where we are looking at those meters, so originally it was connected to the start and not the end. We can flip that service line. And then now we have that proper connectivity. I mentioned that we can write similar business rules for other types of data, whether it's electrical data, whether it's you might have data that is for telco. Travis has mentioned it in the telco space, and what have you. And a lot of times, a lot of these business rules are similar because you're checking connectivity, whether it's an electrical line or a meter. It doesn't really necessarily matter, but maybe it gets a little bit more complicated because we all know that electrical network is a little bit more complicated. But we can write business rules against an electrical utility network. So, for example, one of the validation checks that we're doing is we're looking for, in this case, we were looking at an electrical network. We have above ground conductors, and we're saying that if there's an above ground connector and there's any sort of change in the direction of the conductor, there must be a pole at that location. And we can see here that we have pole data, and all of a sudden we're missing a pole at this particular location. So that's why we can flag this feature saying that this particular feature is missing a pole, and we either need a pole here or this network should be connected this way, because you can't have something above ground where there's not a pole. So those are the types of validation checks. So we can write some pretty complex validation checks when we're going through this. So let me go back to my slides. So we talked about doing validation checks on gas. We can also do it on electric, and we can. I didn't go through every single validation check. It starts to get repetitive when we start going through every single validation check. But we could write validation checks on the electrical data just like we did for the gas data, and they could be specific to whatever your business needs are. This is all leveraging our OneIntegrate technology, and we are, as I mentioned before, we are data agnostic. We can bring in data sets from like Oracle, file geodatabases, shapefiles. We're also partnered with Safe Software, where we can connect into anything that FME can read, leveraging their API. So this is where we can start connecting into CAD drawings and Esri geodatabases and so forth, and bring them all into the engine and write those validation checks across all those different data sets. We also do have an application called the One Data Gateway that is a submission portal where you can collect data from data providers that are maybe providing you data. Travis mentioned the work that we're doing at Google, where they have contractors that are building out CAD drawings of floor plans. And in order to integrate that data into their asset management system, it needs to go through a series of workflows. So what we provide is an application as a front-end interface where they can literally drag and drop their data set into the application. It will run through the validation checks and then give them a report on how well the data is meeting the business needs. And this way, Google can say, we're not going to accept your deliverable until it meets these business needs. So this could be with CAD data, collecting CAD data or GIS data, or even non-spatial data like spreadsheets. It can be written for any of those purposes. The next thing I want to talk about is bringing in CAD drawings into your GIS. This is typically a huge headache for organizations. A lot of times it's done once and it's not done more than once because it's a pretty big headache. You have to get those CAD drawings into GIS space. A lot of times they're drawn in paper space. So if you're lucky, there may be a WLD file provided where there may be 1 or 2 reference points. But even if you only have 1 or 2 reference points, a lot of times all the data is shifted outside of those 2 reference points. So it makes it really difficult to get that data into your GIS without having manual intervention. But within the OneIntegrate rules engine, we can write business rules for how to facilitate that data integration. So we can automate a majority of that process. And we can either do that through what we call positional accuracy improvement. And that's typically where it's somewhat close, but it just needs some shifting, some rubber sheeting. So we can do that automated process for the rubber sheeting. Or there's cases like this manhole use case where the manhole itself isn't completely in paper space and there's no sort of geospatial information. We need to get that into the GIS. So let's talk a little bit about that. So let's take first a look at what we're trying to do, and then I will walk you through that process. So here we have a CAD drawing of an electrical manhole. And what we need to be able to do is we need to be able to get this drawing into the GIS location. And the reason why this client wanted to be able to do this was because they wanted to be able to trace the feeder line all the way from the beginning all the way through the network. And in order to do that, they needed to pull that information from the manhole to determine where the feeder lines were going inside the manhole, and then determine how many times it wraps around the pole and so forth, or wraps around the, I guess I should say, the manhole itself. So in the drawing itself, we have an identifying number. We have 1564, and luckily in the GIS, we also have that information. So I know that this particular vault is where this drawing needs to get migrated into. So leveraging OneIntegrate, we can at least get the data shifted over to that location, but also notice that this particular drawing is not rotated in the same, it's not rotated to due north. So one of the other things we need to be able to do is rotate it around in order to determine what the best fit is. And we can do that leveraging the engine. So let me go back to my slides real quick, and I'm going to walk you through the steps that we're going to do, and then I'll show you inside OneIntegrate how we're doing it. So the first thing we need to be able to do is we need to be able to identify, because this is a dumb CAD drawing, we got to be able to identify what the objects are in the schematic drawing, and in order to determine how to get that data shifted over into the GIS. So leveraging OneIntegrate, we can look at the topological relationship and infer what all these objects are. So to be able to identify where's the floor, which is important for doing the shifting, scaling, and rotating. And then we can find all the other objects, but the most important objects besides the floors is the actual wires, because that's where we're going to have the feeder information in order to determine how the feeder lines are moving through the network. Once we identify the objects, we then can shift it so it's generally in the area because we have that point, and then we can rotate it around until we determine what the best fit is, and running through a series of validation checks as we're shifting it to validate that where do we have that best shifting information. Once we have that shifting variable, we then apply it to all the objects, and then we now have shifted, scaled, and rotated the drawing so that at least the schematic drawing is in the geospatial space. But it's still a schematic representation. So we got to turn that schematic representation into a GIS representation. Well, we're going to connect our wires and add our splices. We're then going to conflate the feeder ID onto the actual network. And then we're going to actually move this into geospatial space. All this leveraging a rules-based approach so it can be automated. So then we can apply those same rules to all the drawings. Now, when I did this for this particular client, we did it on one particular drawing. We then ran it through all the other drawings, and yes, it didn't work the first time. What we had to do is I realized that I wasn't taking certain things into consideration, so I had to go and tweak the rules a little bit more. And then I ran it through all the drawings, and all but 2 came through. And the reason why 2 of the drawings didn't come through is that there was some data quality issues with the drawing itself that needed to be addressed. So we would first do that data quality assessment on the drawings. If they meet those business needs, it can go straight into this automated process. Otherwise, there may need to be some sort of manual intervention at that piece to fix something that's in the drawing so that it can be migrated into the GIS. So then lastly, sorry. And then once we have it all in, we can actually build out those connected feeder lines from start to finish, because we can now trace that along the entire network. So real quick, let's see here. So I'm going to come back to OneIntegrate, and let me go to my NASA example. Okay. So notice here is where we're connecting to the DWG drawing. I'm going to just select this particular data store. So this is how we configure the data store. This is how we connect to different data sources. In this case, I'm connecting to a DWG drawing, but this could be, a Bentley, a CSV, it could be Esri, GIS data sources, it could be Oracle, Postgres, or SQL Server, different, whatever format your data is in. This can also be extended. So this is the set of out of the box and supported through FME examples, but then we can also extend this to connect into whatever data sources that you may have. Most of our customers have something that's within this list, but there may be cases where we might have to add an additional data store. One of those examples here is the Google BigQuery. We added this for Google, so we can add additional data stores. When you connect into that particular data set, it's going to read it in. It's going to understand what the different layers are. In this case, it's a CAD drawing, so we had that information about what the different layers are. If it was this case, here's an example of here's the file geodatabase. In this case, this is where we have the GIS information. So we flip back over to my session. So now what we're going to do is we're going to connect to that CAD drawing. Oh, let's try this again. This was just working. Oh, yeah. That's what happens when you do a live demo. Do I try it again? Am I still connected to my? All right. Well, so much for that. Okay, so I'll just walk you through what we're doing inside of the actual map itself. So we have our particular drawing here, and what we're going to do is we're going to migrate that data into the GIS. And notice how we're also not just moving it over, we're doing that shifting, scaling, and rotating so that we get that into the GIS. And then we're also building the wire in so that it's actually connected over here. Let me actually do this. Okay, here we go. So we're connecting the wire in there. Let me turn. So we have that wire now that we've identified. We've connected into the network itself, and we have applied this to the entire network so that we can trace those feeder lines along the network itself. So here's where we have all of our feeder lines, but then we can look at them, how they're tracing through the entire network itself. So with that, let's see here. I think we are ready for questions.
Haven't seen any questions pop up in the chat yet.
Nope, I haven't either. All right, guys, if you have any questions for Kevin or Travis, please throw your questions into the chat. Kevin, what I thought was super interesting about what you were showing is the ability to take those CAD drawings or those DWG files and automatically extrapolate the features that we would have to heads up digitize. That was super cool.
Yeah, that is something that is super challenging to most organizations that we've been working with. There are tools out there that that are not ours that can get the CAD drawing into the GIS, but typically it's a one-time thing where it kind of just moves it in there, and then you have to do all this manual cleanup once you get it in there anyway. So being able to validate the data before choosing to ingest it, and then having business rules for how to actually get it integrated within your data source can really save a lot of headache and automate a majority of that process.
Absolutely.
Typically, when we're doing these projects, we shoot for about 85 to 90% automation. 100% automation, I like to say, is putting a man on the moon. We're not trying to put a man on the moon, because if we were, it would cost as much as to put a man on the moon. So we're trying to get to 85, 90% so that it's a nice, it can get you to where you need to go. And maybe there's some manual intervention that needs to occur, but it's limited.
Nice. Now, if I was seeing what you were showing correctly, you could bring over those DWG files, pull out the features that you were wanting, and then run validations against that to make sure connectivity was correct, that you weren't missing anything from the document. Because, you know, for those of you that are here, have you ever looked at some of these as-built drawings and you couldn't make out what was there for whatever reason? That's kind of a checks and balance, I think, that you've built into the solution, and I think is fantastic. That's awesome. I like it. I like it a lot. I wish I'd seen this when I was in local government. I can't tell you the number of times I had to pull over an as-built PDF into desktop, rotate it, save it where it was at, and then heads up digitize on top of it. This would have saved me so much time and so much frustration when I forgot to save the project and I lost the image that I pulled in to reference. Never fun. All right, guys. Well, I'm not seeing any questions. So if people want to get a hold of you guys, what's the best way to connect with you?
Yeah, so I believe on that first slide that Kevin's bringing up, we will have our email addresses on there. We do have a website as well, onespatial.com, and there'll be a number on there that you can reach. But email is usually the easiest and best way. We'll respond pretty quick.
Absolutely. So guys, take down their contact information, reach out to them and let these guys know what you thought of the presentation. I'll be reaching out to you, Kevin and Travis, to see about doing more of this stuff with you guys. I know that you guys are all over the place. You're in a ton of different markets, and that's who we support. So what else can we look at that's either related to pipeline or related to a different industry like public safety or 911?
Yep, exactly. Yeah, on the 911 side, we're working with a lot of the groups on the next gen 911. We've taken all the NINO standards and kind of built those into rules, kind of ready to go. And then we're also looking to do the same thing on the PHMSA side as well, to bring those rules into OneIntegrate and bring those PHMSA rules in there.
Yeah, that's going to be massive. There's been a lot of stuff going on with PHMSA over the last year and a half, 2 years. So it's cool to see that you guys have started integrating that into your solution. That's awesome. All right, Kevin, Travis, thank you so much. I really appreciate you guys hanging out and bringing us this content. I knew who One Spatial was, but I had no clue what you guys did. Now I have such a better idea. So thank you so much.
Excellent. We appreciate it.
Thank you.
Yep. Everybody have a happy Thanksgiving and look forward to connecting down the road.
Absolutely. We'll definitely be in touch. Thanks, guys. Y'all have a good one.